Hi everyone, I am excited about our lesson today on algebraic expressions. Algebra is one of my favorite things to do in math, so I hope you like it as much as I do. Alright, so our first thing is we want to make sure that we know what an expression is. So a numerical expression is a math problem that does not have an equal sign. It's really that simple. It's just a problem without an equal sign. Now an algebraic expression, which is what we're going to be working with today, is an expression, meaning it doesn't have an equal sign. It's a math problem without an equal sign. But this contains at least one variable, and it usually has constants and operations. Again, it does not have an equal sign. So let's look down here at some examples of expressions. 2 plus 7 is an expression because it doesn't have an equal sign. 9, this means times c. Whenever you see a number and a letter together, it's a multiplication problem. Plus 15. And this is a constant because it's not a variable. This one's a variable, and the number in front of a variable is called a coefficient. Let's just go ahead and label those. So a constant is a number that doesn't change. The variable is usually a letter that stands in for a number, an unknown value we don't know. And then a coefficient is a number in front of the variable that is being multiplied to the variable. Alright, so we've looked at some examples of things that are expressions. These are not expressions. These are equations. They have equal signs. So 2 plus 7 equals 9 is an equation. 35 times a equals 70 is an equation. So our job today is to take these phrases and turn them into math problems. And the reason that we want to do this is because it's a powerful device for us to be able to use when we're problem solving, which is one of the main reasons that we do math, so we can solve problems. So we want to look at some words that would indicate a certain operation. So first of all, let's look at plus operations. So we would know that for addition, we could have words like plus, more than, added to, increased by, total, in addition. And then the answer to an addition problem would be the sum. So any of these words would indicate that the operation that we want to do is addition. Now some words that would indicate that we want subtraction. The answer to a subtraction problem is going to be the word difference, but other words that would indicate subtraction: take away, minus, subtract, subtract from, take away from, less than, decreased, decreased by, deduct. Some options for words that might indicate that we're going to have a multiplication problem. Product is the answer to a multiplication problem. Multiply, multiply times, times by, multiple groups. And some words that might indicate that we are going to be dividing. Quotient, that's a NT there, not a D. Quotient. Divide, divided by, broken up into equal groups. Those are all going to indicate division. Okay, so here's how this works. I might have a phrase like this: 3 increased by a number, and I would translate that to 3 plus n. When it says a number, that means I can use any variable that I want. X more than 7, start with 7 and add x. The sum of 2 and r. The sum is an addition problem, 2 and r. So here are some example phrases and then their translations. Now subtraction is probably the trickiest one here, so let's take a minute to look at these. My first phrase is 7 minus a number, so I start with 7 and I subtract a variable. I chose n. The next one is the difference of 3 and q. The only way that we can tell whether 3 or q should come first in this phrase is that 3 comes first in the phrase and then q comes second. So the difference of 3 and q, we just write it in that order. That is not true with the next phrase. The next phrase says 4 less than y. So that means we want 4 less than something, which means we have to start with y first and subtract 4. So this one's a reverse problem. We've got to reverse that order. Be careful with that phrasing. 4 less than. Less than what? Less than y. All right? So that one's reverse. Okay, for multiplying, we have the product of 3 and q. Remember, when we are using a whole number or a number and a variable, we don't have to put an operation symbol between the two. We know that this is multiplication. So this means 3 times q, not just 3q. And then this one is the 92 times x. This is how we would write 92 times whatever x is. This means 92 times x. All right, a couple of options for division here. The quotient of 54 in W, just like with subtraction, we know that 54 is being divided by W because of the order in which it's written. So those just go in the order. The quotient of 54 in W, 54 divided by W. Another way to write a division problem is 54 fraction bar W. That means the same thing, these two. 35 divided by Y, 35 divided by Y, or 35 over Y. All right, let's look at a problem-solving situation here. If Delilah bought pizzas for $12 each, now we're repeating something there that should indicate to you that it's repeated addition, which might think multiplication, and P represents the number of pizzas she bought, write an expression to represent her total cost. So we know that she paid $12 for each pizza. So if we take 12 times P, if we knew what P was, we could figure out the total cost. So the expression we're looking for there is 12P. All right, our next one here says if Gina's recipe calls for 2 teaspoons more than Greg's recipe, and G represents Greg's recipe, or Greg's amount of sugar, write an expression to represent how many teaspoons of sugar are in Gina's recipe. So my keywords here, more than, she's got more than Greg. So that means we're going to start with Greg's amount of sugar. G tells us right here that G is his sugar, and we're going to add 2 more. So G plus 2, which be an expression to tell us how much sugar Gina has in her recipe. We'll look at the last 2 problems on that list in your SWIC today. I want to give you one more thing before we end these notes, and that is writing an expression to represent perimeter and area of rectangles. So you may remember from your 5th grade work that to find the perimeter of a rectangle, we're going to add all the sides together. And you might also remember that opposite sides of a rectangle have to be equal. So even though these 2 weren't labeled, we know their values because they're the same as their opposite sides. So to write the perimeter of this rectangle, we would do 13 plus 5a plus 13 plus 5a. So this is one option, but we can simplify that. We can combine like terms. Since the 13s are similar, they can be added together because they're numbers. And then the 5a's, they have the same label on them or the same variable, and so they can be added together too. So this can be simplified to 26 plus 10a. Just like you have proper English, we also have proper math form. And when we write something in proper math form, we usually have the constant, the number that doesn't have a variable, tacked onto the end there. But either of these answers is fine. This is just more mathematically eloquent. And now the last one we'll look at in our notes then is for area. We would write length times width, or you might call that base times height, but it's going to be 13 times 5a. So this is acceptable, or you could also write 13 times, this is called the quantity 5a. This is another way to write a multiplication problem. Okay. Let's take all of this info and move on to our SWIC now and just really solidify what we've been talking about.